Hardi Tilwani. I'm a fourth year student here, pursuing a major in life sciences and a minor in philosophy. And today, here with us, we have Dr. Joshi.
Right. Yeah, well, I'm actually very gratified to hear you have a minor in philosophy. I never formally trained in philosophy, but I have great interest in the philosophy of evolutionary biology as well as being an evolutionary biologist. We actually do some work in that as well. So very interesting to hear that.
So then let me begin by asking some questions that are tangential to philosophy of science as well. So science often is seen as this technical step-by-step process. So you do certain steps and you get to a certain result. How true do you think that is?
I think that's in part true, but it's true of other creative activities than science also. As a matter of fact, a few years ago I had come here to Ahmedabad University and given one of your Nalanda talks on the art of science and the science of art, where I made exactly this point that to everything there is a sort of a creative, more poetic sort of aspect, there's a more technical aspect, and that is true of science as it is of poetry. In poetry also you have technical issues of meter and various rules of how you can combine words and sounds and so on in science, but there's also creativity. So I think the point with science is that sometimes there's a tendency to get bogged down with the techniques, but the techniques are not the science. Neither are the facts the science. Science is in our head. It's the conceptualizations that we build up to explain the patterns that we see in the way the facts present themselves to us. So that is really where the science is. We often get confused and think it's in the facts or in the techniques by which we learn the facts. That's part of it, but that's not really what it is in its essence.
But there is this looming misconception that still goes around. Why do you think that is? And should we have a change in education?
I think that's partly because of the way science is taught in school. It's taught as a collection of facts, and very often you don't even get a properly detailed appreciation of how exactly those facts were arrived at and how many wrong movements happened, wrong paths were taken, and all that. So I think we need to teach science as a process of creating conceptualizations or explanations for things rather than as a collection of facts or as a collection of understood knowledge. I think we need to teach at the school level more in terms of the process of how we do things.
And lastly, I would like to ask again on the similar part. Do you think we should make the failures of science more explicit in a way, the failures of the theory that have been through the history of science?
Yes, absolutely. The failures are very important. Professor Gadakar, who is here also, is fond of saying that theories in science are like candles. They eventually burn themselves out. But while they are around, they shed a lot of light. And that's pretty much it. I think so. If a theory provokes a lot of empirical work, which eventually leads to that theory perhaps being discarded, but in the process has led to a lot of insights because of all this work, then the theory in some sense has served a purpose. And I think failure should be emphasized. Also, the other thing that should be emphasized more than specifically failures is how, see, the way scientific papers are written, scientific talks are often given. It's like this was the hypothesis, and then we did this experiment and this experiment. Clean, linear story, and that's not usually how science happens. It's usually more like there was this weird thing we noticed by accident. And then we started wondering what it was, and then we did some preliminary stuff, and then we started coming up with some preliminary hypotheses, and then this thing iterated 57 times, and we understood something at the end of it. But that's not how you write it up for the paper or how you give it in a 30-minute talk. And I think it's probably helpful if this aspect of how science moves forward, not in this very linear fashion, but in a way that often involves a lot of chance and so on. I think that should come out a little bit more in education, at least in the college level education.
And because scientists are often viewed as these monotonous people, I would really like for you to share some of your favorite poetic pieces.
Favorite poetic pieces are hard to find. I'll give you a couplet of my own.
Sure.
Um, जिंदगी के कारवां में हैं तो तन्हा फर्द सब अक्सो साया देख वहमे हम रवां क्यों दिल में says that in the journey of life every individual ultimately is alone. We see our shadows and our own reflections, and we mistakenly think that there are lots of people walking with us.
That's beautiful. Thank you so much for this interview.
My pleasure. You're most welcome.